Hello, everybody. Today, we are going to learn about graph transformations. This is all about how we can take a graph and move it around the coordinate plane. So let's take a look at your notes and go to the warm-up. This might be a good time for you to go ahead and pause the video so that you can read the instructions and see what it is that it's asking you to do. Well, I'll go ahead and read it first. For each of the following graphs, explain how they are different from the original graph. So the original graph is right here. Then I want you to look at number 1, 2, and 3 and tell me how they're different. Go ahead and pause and then play again when you're ready. Okay, so let's see what you observe. If you notice, the original graph, you got to make some observations here, okay? The original graph, look at the what we call the vertex, right over here. That's right there at 0, 0. If we come to number 1, what happened to that vertex? It was here. It looks like it went down 1, 2, 3. Everything else seems to be the same. So we're going to just say it went down 3. I use arrows because I don't like to write full words out, but you can go ahead and write down 3 if you really want to. What happened with number 2? Check it out. The original vertex, again, was here. But what happened was that this graph moved to the 1, 2, 3. It moved 3 to the right. So it went to the right 3, or you can actually write out the word right. Okay, look at number 3. Number 3, though, if you notice, it's at the exact same vertex. But do you notice what's different about it? The original one, right? If you start from the vertex, remember rise over run slope? From the vertex, I would rise 1, run 1, and that would get me to the other point. But here at the original, look at number 3. I'm at the vertex, but if I go up 1, over 1, that's not an intersection anymore. I have to go up 1, 2, 3, 4, and then over 1. And that's a rise 4, run 1, which makes it have a kind of like a slope of 4. So we say that it dilated, okay, or you could say that it, another word for this is it stretched, okay? Alrighty, so let's go ahead and start writing down your notes. All right, what effect does replacing f of x with f of x plus a or f of x minus a have on the graph? So in other words, I'm going to give you an equation, you guys, and then I'm going to do stuff to that equation, okay? So for example, look over here on this graph where I'm writing. Let's say I gave you f of x equals x. That is my graph, or y equals x. I'm going to do all kinds of stuff to that x today, y'all. I'm going to add 2, maybe make it an x plus 2. Maybe I'll subtract 3 and make it an x minus 3. What does that do to the graph? That's what this is saying. If I add a number or subtract a number, what will that do? Okay. So if we add a number, okay, like if I said plus 2, go ahead and write this down, or subtract a number, we're going to shift this thing up or down that number of units. So if I said x plus 2, that means the graph is going to move up 2. If I said x minus 2, it's going to go down 2. It's called a vertical shift. It's when the graph moves up or down. So that's how we're going to talk about it. I'm going to say, what's the vertical shift? Remember that vertical up or down, right? Kind of does that. And you're going to explain that to me. Oops. Okay. All right, so here's an example, you guys. This graph that you're looking at to the right-hand side is this equation over here. I'm trying to highlight it. It's kind of, there we go. So it's the absolute value of x, and look what I did to it. I added 2. That's what I just did to that equation. I added 2 to the equation. So What am I going to do now? I'm going to take that equation or that graph, and I'm going to move it, because it says +2, I'm going to move it up 2. So let's copy down the blue graph here going up 2, making a vertical shift up. So here's the vertex. So that's what I usually move, is the vertex first. So I go 1, 2. All right, so that's over here now. Okay, and now I need to go ahead and graph my lines, but y'all make an observation here. The original one went up 1 and over 1. So with my new one up here, just shifted up 1, it should also go up 1 and over 1, and do the same thing to the other side. And now what you could do is go ahead and draw your line. Okay, that is our new graph. So you just graph that line, or that what we call absolute value function. All right, let's do another one. What if, okay, this time it's saying what if. I'm going to give you, like, here's an example. F of x equals, so this is the equation that we're going to be messing with the most today, that absolute value of x. What if instead of saying +2 on the outside, like what we just did, what if I had a +2 on the inside? That's what it's asking right now. So I'm looking at this. You see that x plus a is on the inside of the parentheses, or that minus a is on the inside? What will that do to the graph? Okay, that's going to shift it left or right. So when it's on the outside, it goes up or down, but when the number's on the inside, it's going to move it left or right. But there's a little trick to it, so be careful. All right, so you wrote down left or right. Okay, go ahead and write down this one right here. Says x plus a, and that's on the inside. It's going to shift, believe it or not, although it says plus a, we're actually going to shift it to the left a units, whatever it was. So if it was x plus 2, we would go left 2. Down here, x minus a, it's a minus sign, which most people think you're going to end up going left, but you're actually going to move to the right that many units. So if I had x minus 2 on the inside, you're going to shift the whole thing to the right 2. Okay. All right, so this is no longer vertical. Vertical is up or down. This is a horizontal shift, and it's when a graph moves left or right from a fixed point. Did y'all get that? Horizontal shift? Pause if you need to. Now we're going to sketch this graph. Okay, so check it out. You see that +4 that's over there in the equation? You notice how that's inside of the absolute value? Okay, we're not moving it up or down. Okay, if it was on the outside, we would move it. If it was out here like this, then it would go up 4. But that's not what it's doing. It's on the inside. So we're going to move it left or right. What do you think? That's right. We're going to move it left, right? Because that +4 means to go left 4. So watch how I do it, and then you draw it. That's my original vertex, and then go 1, 2, 3, 4 to the left. Same slope as the one that's original, up 1, over 1. And then you're going to draw your lines. And you're done. You just shifted that whole graph to the left 4. Pause if you need to. What effect, all right, what effect now are we going to see? Because replacing f of x with negative f of x. What if we threw a negative out front? So, for example, what if it looked like this? F of x equals negative absolute value of x. That's a negative on the outside, out there in the front. What is that going to do to it? So the graph is reflected. We're going to flip the graph over the x-axis. So we're going to, here's an example. This is what I mean by reflecting over the x-axis. This, y'all, is the x-axis. Do you agree with me? Okay, good. When we say I reflected over it, that means I'm going to take this original graph and literally flip it over that red line that I just drew, that x-axis right there. What would it look like then? So the vertex would stay exactly where it is, right? But then, instead of going up 1 over 1, I'm going to go down 1 over 1. It's just going to be kind of like upside down, isn't it? It's going to look like that. Okay. That is reflected over the x-axis. We're going to do one more reflection. Okay, what if it is replacing f of x with, do you see the difference between this one and what we just did, you guys? Take a look. Do you see that negative that's right there? The one before, the negative was in front of the f of x, but this one, it's on the inside. So what we just did was that. But what we want to do now is put the negative on the inside of those absolute value. All right? So what do we do with that? Before it was an x-axis reflection. What do you think it's going to be now? That's right. It's going to be a y-axis reflection. So let's go ahead and write this down so the graph is still reflected, but it's reflected over the y-axis. A reflection is when the graph is flipped. Pause if you need to. Okay. Sketch the example in the graph. So this might blow your mind a little bit, but here's the deal. This is what I do for a y-axis reflection. Imagine, do you see the y-axis right here? All right, that's the y-axis. Imagine that this blue line in front of you, right? Imagine that it's wet paint. And I'm folding it right there on that green line on the y-axis. So fold the whole paper over, pat it down, then open it back up. What are you going to get? It's going to be the same thing. It hasn't always become that way, but in this particular case, it's the exact same thing. So that's how we do a y-axis reflection. Okay. All right, next thing. Let's, one last thing is, what effect does replace f of x with some number basically multiplied by f of x have on a graph? Multiplying the function by a number. So what we're going to do is we're going to take a number, like let's say 2, and then multiply that by x. What does that do to it? All right, so the graph is what we call dilated. Okay, a dilation when a graph is, and the words are, you might remember this from the warm-up, it either stretches or it shrinks. If the number that I am multiplying it by happens to be bigger than 1, okay, then that's going to be a vertical stretch. And a stretch means that it's going to get like kind of like thinner, kind of like that. When a is a number between 0 and 1, then it represents a vertical shrink. And funny enough, it doesn't look like it shrank. It looks like it got bigger, but it gets like wide, kind of like that. All right. So let's do it. Let's do 2 examples here. I'm going to do them in 2 different colors. Okay. So for this one, for number 5, 1/2 times the absolute value of x. Y'all, this is a number between 0 and 1. That's going to be a stretch, but check it out. Let me show you how to do it. Do you remember how we did slope as rise over run? So 1/2, starting over here, I want you to do the same thing. So I'm going to go rise 1, run 2. But because this is symmetrical, I want you to do it in 2 different places here. So go rise 1, run 2 to the right, 2 to the left, like that. And then draw your V. There you go. That's number 5. That's your shrink. And then number 6, wanted you to do a stretch. That's a 3. Well, we could write 3 as 3/1. Remember, rise over run. So starting at the vertex, rise 3, 1, 2, 3. 1 to the right, 1 to the left. So one's going to be here, one's going to be there. Rise 1, 2, 3, 1 to the right, 1 to the left, and then draw it. You could draw it better than me, probably. So that's your number 6, and we just stretched that. Okay. Alrighty, so this is the order in which we like to graph. You always want to do your horizontal shift first, then your reflections, Then do your vertical shift, meaning left or right, up or down. Then do your dilations, your slope, rise 1, run 2, or rise 3, run 1. And we call that Harvard or Harvard, however you want to say that, just to help you remember the order. And that's also already on your notes, but go ahead and pause it right now, and you can fill those in. Okay, let's summarize what we've done. The following transformations can be made on any graph of any function. Number 1, horizontal shifts or translations. When you have a +3 or a -3, some number inside of the parentheses or inside of those absolute value functions, it's going to shift to the left or to the right 3. Number 2 is our vertical shift. That's the up or down. That's when the numbers are being added or subtracted on the outside. So make sure that you can see the difference between that. We're going to move it up 3 or down 3. Now I'm moving fast so that you can, because I know that you can pause. Make sure you're writing these down. Number 3 is reflections. When the negative is on the outside, okay, that's a reflection over the x-axis. When it's on the inside, that's a reflection over the y-axis. And the last one is your dilation. Depending on what that number is that's being multiplied, if it's bigger than 1, we call that a stretch. If the number is like a fraction that or a decimal between 0 and 1, that is going to be a shrink. Sorry. Let's see, did I miss something? Oh, and the last one, of course, is the order in which you're going to graph. HRVD, horizontal, then reflections, vertical, then dilation. Okay, so what I want you to go ahead and do is, now that you are done, you need to go ahead and begin on the homework. As you finish, please bring it up to either me, Mrs. Gary, or Miss Lewis, so that we can check it off.